Hey guys, this is Britt Caswell with another example video. This is example 1 from lesson 1-5 in the SavvasRealize Algebra 2 textbook. In this example we are looking at how to use a graph to solve an equation. This textbook tends to embed a lot of graphs from Desmos. Okay, so Desmos.com, that is the graphing software they use. So some of their examples, you'll see the Desmos graphs. Some of them you'll see ones that are generated just from the book. But I highly recommend that you download the app to your phone, the Desmos app to your phone, or that you have a tab open to Desmos.com, because it's a really user-friendly graphing calculator, and it'll save you time from doing it by hand. So here we are, we have an equation, this is part A, and on this equation it has an expression on one side and a value on the other side. So when we want to solve an equation just by graphing, we could do that. We don't have to go through all the algebra. Now I normally frown upon graphing because it tends to produce approximate solutions. Like if you have an answer that's like 30.0012 or something like that, you would probably truncate your answer at 30 or something like that, depending on your graph. And so I don't like graphing because it tends to leave a little bit of ambiguity. However, I'm still going to show you how. So with this equation, what I'm going to do is I'm actually going to split it into two equations. Okay? I am going to take this first part and I'm going to call it f of x. So f of x equals negative 3x plus 20. On my graph, that's this blue line, right? You see the y-intercept here at 20. The slope is probably negative 3. You just have a hard time seeing it, and that's okay. Alrighty, so then I'm also going to take the second part of the equation, this 5, and I'm going to call it another function name, probably g of x. It doesn't really matter what letter you use as long as you say it's a function. And so this red line is the function 5, right? So y equals 5. That's why it's a horizontal line. It doesn't matter what the x value is. So the solution to the equation, we know that there's one answer here, right? I could do some quick maths here, right? I could subtract 20, get negative 3x equals negative 15, divide by negative 3, and get x equals 5. I could do that with arithmetic, which I encourage. But see, there's only one answer. The answer is not the whole graph, it's just a single point. And it's the point where these two lines are intersecting. You guys see that? So these are intersecting at the point 5, 5, and the answer is just the x value. It is not the y value, because we're searching for x. Let's try another one. Alright, so part B. The first equation is the absolute value of x minus 4. Okay, that's this V shape that's on the graph that you see there. And the second equation is 1/2 x plus 1. It's a linear equation, right? There's no hanky-panky going on with the x. So on this one, notice that there are two solutions. There is one point here at 2, 2, and one point here at 10, 6? Yeah, 6. Okay, and the x values are the solution, so the solutions are x equals 2 and x equals 10. Remember, absolute value functions often produce two solutions. Okay. So now here's another one. This one's done on a Desmos graph. So whenever you see graphs that look similar to this is on Desmos. And so what I did was I used I typed it into the calculator. Okay, I said f of x is 5x plus 12. That's this red line. And I said g of x was equal to 3. Okay, that's the blue line. And so these 2 points, these 2 lines are intersecting right here. And the ordered pair for that is at 3, 3. So the solution is at x equals 3. Now, what I want to do is I want to show you something kind of strange that I encountered with your textbook, which I also encountered it on the Desmos computer too. So if I didn't type in the f of x, for the first one it graphed it. But then I put 3 in the next line and it wouldn't graph. It wasn't until I put f of x and g of x in front of them and put the equal sign that it populated the two graphs like you see here. So when you guys go to do it in your textbook, make sure that you put the f of x and g of x there, or else it won't graph properly. Alrighty, so then here's another one. Desmos picks random colors for their graphs. So the first one is orange. There's my f of x that I typed in there. The second one was the negative 1/2 x minus 2. And notice, guys, that the colors that they put here are the colors of the lines. So you can tell which line goes with which equation, which is really nice. So my points of intersection are at, sorry, that's backwards, 0, -1, right? Oops. So your x value is 0, your y value is -1. And this point here, what is that point? Oh, this is counting out to 10, so each of these boxes are worth 2. So make sure to watch your scaling. You see that? So check out these numbers and make sure that you know how much each box is. So I originally thought this was -1 because I didn't look at my scales. But each of these boxes is counting by 2, so that's why the scale out here is 10. So this is actually at 0, -2. Okay? So if these boxes are counting by 2, this one is at 2, 4, 6, 8 on the x-axis. And then 2, 4, 6, that's at -6 on the y-axis. Alrighty, so my two solutions then would be x equals 0 and x equals 8. Alrighty, so that is it for example 1. Until next time.